Chapter 4 is arguably the most difficult chapter of the entire course. Not surprisingly, this exercise set lives up to it. It's gonna be a challenge. Even so, despite that, this exercise set does not cover Chapter 4 like a blanket in its entirety. That'll be impossible. It focuses upon only one aspect of it, the addition rule and some logical, critical thinking. That's about it. And there are some other topics like independence, tree diagram, conditional probability, and so on. There are many more. And you'll have to spend your time studying with my notebook or WebAssign or Alex textbook and so on and so forth in order to prepare yourself for exams and other kind of assessments. In any case, let's concentrate upon addition rule and logical thinking with this exercise set. Here we go. This is the first problem. A travel agency surveyed 125 potential customers. The following information was obtained. 68 wishes to travel to Hawaii, 53 wishes to travel to Las Vegas, 47 wish to travel to Orlando, and we have circles for Hawaii, Las Vegas, and Orlando. And then the problem goes further. Moreover, 34 wish to travel to Hawaii and Las Vegas, 26 wish to travel to Las Vegas and Orlando, 23 wish to travel to Hawaii and Orlando, and finally, 18 wish to travel to all three top destinations. And there may be some people who listed some other location, not those top three, and those people will go outside. Now, here are some problem sets associated to this. Okay, here we go. If you select a customer at random, what is the probability that the selected customer wanted none of the top three destinations, so the people who are outside all three circles? Next, what's the probability that the selected customer wanted to travel to Orlando and Las Vegas, but not Hawaii? 1.3 is very similar except that Orlando or Las Vegas, but not Hawaii. The difference between 1.2 and 1.3 are and versus or. And these two make a world of difference. Number 4, and probability that selected customer wanted exactly 2 of these top destinations. So Orlando and Las Vegas, Hawaii and Orlando, or Las Vegas and Hawaii, those kind of things. But not all three. 1.5 is a little bit different. It says at least 2, so that includes all three as well. So this is exactly 2. This is 2 or more. 2 or 3 for 1.5, exactly 2 for 1.4. So we have subtle difference between 1.4 and 1.5, and we saw a subtle difference between 1.2 and 1.3. How do we handle this problem? We use addition rule, yes, but even more important technique here is critical thinking skill, logical thinking. Now, the only good way to answer these problems will be to complete this Venn diagram, putting appropriate numbers in there. And let me show you a wrong solution first. Let me copy and paste the problem set here. And I'm afraid I see these kind of answers a lot. Almost every semester, I think I've seen students doing this and earned pretty much 0 credit because this is wildly wrong and really wildly wrong at the very first step. And also, the very first sub-problem actually is intended as a hint to correct this thing but didn't see it. Well, which means, of course, the students didn't have any kind of understanding about probabilities, so 0 credit is well deserved, but still it hurts. 68 wishes to travel to Hawaii, so blindly write 68. 53 going to Las Vegas, so 53 here. 47 going to Orlando, so 47. 34 wishes to travel to Hawaii and Las Vegas, so 34. And 26 going to Las Vegas and Orlando, so write 26 there. Finally, 23 wishes to travel to Hawaii and Orlando, so that goes here. Oh, did I say finally? There's one more, excuse me. 18 wishes to travel to all 3 top destinations. That goes right in the middle, 18. Now, if you do that and try to solve the first problem, which is intended kind of as a hint, you're going to fall into trouble because adding up all these numbers, you're going to get a number that's exceeding 125. That's impossible. The survey is based upon 125 potential customers. How can you get a number bigger than that? And of course, if you subtract bigger number for 125, you're going to get negative number of people outside. That doesn't make much sense. Just plain impossible. So how do you work it out? Well, use your critical thinking skills. How did you end up with more than 125 people out of 125 total? You must have double counted, triple counted some people. Indeed, that's what's going on here. 68 people who wanted to go to Hawaii. That 68 corresponds to entire H circle here. Not just here, but this 68 includes the people who want to go to Las Vegas and Hawaii, or all 3 destinations, and so on and so forth. So 68 here, this is wrong number. 68 must be shared by all these. And some of them are already counted, double counted, so you have to subtract appropriately. And the same goes for 53, which should be shared by entire circle here. Likewise, how about this 23? 23 people wish to travel to Hawaii and Orlando. That means Hawaii and Orlando. This football shape here, that football shape corresponds to 23 people. And 18 people wanted to go to all 3 destinations. So this number right over here should not be 23, but 23 minus 18, because this over here and all 3 inside should add up to 23, and so on and so forth. So that leads to a conclusion that only one number out of all these are correct. Only one number is correct. Everything else is wrong. Which is it? 18. The middle number is correct number. Everything else is wrong. Why is that correct number? Because that's all the way inside. And there's no room for double counting here. So that's where we start. Now let me show you the correct solution. Or correct Venn diagram, excuse me. Okay, here's a correct Venn diagram, and there's a problem I just copied and pasted. And we begin with 18 in the middle. And next, let's work out the people who are going to Hawaii and Orlando. There are 23 such people, and 23 should be shared here in this football shape, Orlando and Hawaii. 18 is already selected, so what's left? We get this subtraction. 23 minus 18 is equal to 5. That's how we get 5 here. Next, 26 people want you to travel to Las Vegas and Orlando. 26 should go here in this football. Las Vegas and Orlando. 18 are already selected, so we have this subtraction. 26 minus 18 is 8. That's how you get 18 there. That's how you get 8 here, excuse me. Now, how do you get the 16 over there? It's coming from the same subtraction. We had 34 people that belong to this entire football. 18 is already counted. 34 for this entire football, 18 over here. So what's left outside? Subtraction, 34 minus 18. That's how you get 16. And this kind of analysis covered up to here, backtracing the problem. Now let's further backtrace the problem. Let's consider Orlando. 47 wishes travel to Orlando, and that corresponds to this entire circle. 47 goes to this entire circle, and 5, 18, and 8 are already there. So subtracting these numbers that are already there from 47, we have 16. That's how you get 16 here. Further backtracing, we have 53 people who wish to travel to Las Vegas. 53 should be shared by this entire circle here in L, and 16, 18, 8, those are already there. So subtracting these away from 53, we get 11. That's how we get 11 there. Similar consideration yields 29. Those people listed only Hawaii out of those top destinations. Now, if you add up all these numbers now, that will be the people who selected either Hawaii or Las Vegas or Orlando without double counting. And subtracting these people out of total 125, finally you're going to get the number of people who listed none of those top 3 destinations. That's 22, and the 22 goes outside. This completed the diagram. Now that you have complete diagram, you're ready for the problem. Well, here's this problem set. Let me open the solution, and we have duplicate of all those problems here. And let's see. Let me copy the problem here. This was the original problem here. And then none of the top 3. Well, how do we handle that? Well, okay, here. None of the top 3. So these 22 people out of total of 125, we end up with 0.176. That's the probability. Easy. If you just use wrong solution, you're going to get a negative number there. At that moment, you have to actually see and come back. But to tell the truth, I have seen far too many students who didn't do that. That simply tells us that the students did not understand the basic idea of probability. That's your credit. That's fair. Next problem. Orlando and Las Vegas, but not Hawaii. What is that? Orlando and Las Vegas. Well, here we go. Orlando and Las Vegas, that means inside Orlando and also inside Las Vegas. That corresponds to this football where my mouse is moving around, but not Hawaii. So this 18 is inside Hawaii, so we have to go out. I only have this one number, 8. And that's the only one highlighted in green here. So what do we have? 8 out of 124. There goes the probability. That's how you get the probability for Orlando and Las Vegas, but not Hawaii. Orlando and Las Vegas, but not Hawaii, so come out. What's the next one? Orlando or Las Vegas. So Orlando or Las Vegas, so inside or inside L, everything put together. So 16, 11, 18, 8, 5, 16, all those numbers inside the snowman or figure 8 correspond to Orlando or Las Vegas. But then again, but not Hawaii, so we have to go outside of Hawaii circle. So this 16, 18, 5, those are wrong. We only have highlighted number. This purple, and that purple. Adding those highlighted numbers, the purple numbers up, and dividing by the total of 125, we get the probability, 0.28. So that's the difference between Orlando and Las Vegas but not Hawaii versus Orlando or Las Vegas but not Hawaii. It's more of a logic than rule of probability. Critical thinking skill to be a little bit more precise. Next, what's the difference between exactly 2 versus at least 2? Here's the illustration. Exactly 2. These 16 people listed Hawaii and Las Vegas, 2 locations out of these top destinations, but not all 3. This number 5 corresponds to Hawaii and Orlando, only those 2. This 8 corresponds to Orlando and Las Vegas, only those 2. So adding up these brown numbers and dividing by a total of 125, we get the probability. That's for exactly 2. Next problem is about at least 2. This time, not just brown numbers, but this blue number as well. 2 destinations or 3 destinations put together. So adding all those and dividing by 125 the total, we get the probability of 0.456. That concludes the problem number 1. And let's discuss problem number 2 in a separate video.